Good morning.
Good morning, Francesco. Aletta, do you want to go next?
Okay, sure. Aletta Higas from the UP Marine Science Institute. I've been my research focus has been it's biological oceanography in general, a lot of more on fisheries and harmful algal blooms, and but I do a lot of more ecological modeling, and I've been working with Nadia and company for with CoastPredict, and hoping, it's been an exciting definitely exciting times, and I think a lot of potential for our collaboration. So thank you. Maybe
Maybe Francesco, do you want to go next then?
Yes. Hi everyone. I'm Francesco. I'm working at CMCC in Bologna, and I'm working on numerical modeling, ocean numerical modeling, especially high resolution modeling. I work with Nadia since 2013, and in all this period we developed this relocatable ocean model that we will use in this project.
Mirad.
Hi, good morning, everybody. I think I've met some people in the Philippines before, at least online. So my name is Marita Donovan. I lead the CoastPredict Secretariat. And I want to say thanks to Aletta for kind of driving the initiative to make this workshop happen. We've been talking about it for a while. We had a meeting last September, I think, with people who are online as well today. And it was one of the things that came out of the CoastPredict General Assembly this year, was just the need for this sort of training. So it's great that this is the first. And thanks everybody in CMCC and in the Philippines for making it happen.
Thanks, Mirad. Rita, why don't you go ahead?
Yeah, thank you. So good morning again, everyone. I'm Rita Lecci. I work at CMCC since a long time, around 18 years. I'm an oceanographer, and I work in the field of operational oceanography in the framework of Copernicus Marine Service. Thank you.
Janelle? Maybe, I don't know if you can hear us.
Oh yeah, so for the Philippines side, maybe I know Janelle or Lay. No, I think Janelle.
Let's do Paul Del Rosario, if you can hear us.
Should I connect? Yeah. Okay. So sorry, we're having some difficulties technically, but hi everyone, I'm Aiko Del Rosario. I am currently the co-project leader of Visayan Sea Model for Operational Oceanography here in the Philippines, and I'm lead one of the pilot sites in the Philippines for Surf Nemo modeling. So that's it.
Thanks,
maybe
Aiko.
you can introduce the ones there too, Aiko. I don't know. Everyone there in the big room.
Yeah, it seems like there's quite a lot of people in that room.
Hi, I'm Cesar Villanoy, faculty here at Marine Science Institute. I'm in physical oceanography. We're presently busy doing operational model for oil spill in Manila Bay.
That's an interesting one. So what happens now in the Manila Bay? Did you get already oil on the beach?
Yeah, in almost two-thirds of the coast And they're still haven't started siphoning oil from the sunken tanker. So
Okay.
it's not, yeah.
Thank you so much. Leilani's? Hi there.
Hi, good morning and good afternoon. My name is Ailani Valera, and I'm also with the rest of the group in the Physical Oceanography Laboratory, just working for fun.
Nice to meet you.
meet you.
Okay, thank you. So, Patrick?
Patrick, are you there?
Hello, good morning, good afternoon. I'm Patrick Cadilinia. I'm a graduate student under Dr. Aleta Iniguez and worked with her since 2013. My primary research is actually coral, more on the coral ecology side, but I have dabbled with projects under modeling of ecosystems.
Sounds great. Thank you. Did
Thank
we
you.
miss anybody?
The other two in the room?
Hi, everyone. Hi, everyone. My name is Janelle. I'm
Hi.
here
Hi, Janelle.
I'm from the Physical Oceanography Lab, and I'm new to the modeling scene, but I'm very excited to learn from this workshop.
Perfect. So hopefully you'll get to learn something today.
Yep. Hi, I'm Chloe. I'm also in the same project with Janelle. Also a juvenile in terms of modeling, but yeah, I mean, we'll
Can I
see.
also call Paul to introduce himself? Paul?
Sure, Bob, go ahead.
Hi, hello. My name is Paul Del Rosario. I'm also from the Visayan Sea Model for Operational Oceanography, or VISMO. I'm with Miss Aiko.
Thank you so much, everybody. Thanks a lot for being here. And thanks again, Aleta, for arranging this as well. Before we jump in, Aleta, would you like to maybe do a little bit of an introduction in terms of the objectives of this workshop and what can everybody expect to gain from it?
Yeah, I mean, this will be really short. But essentially, I guess I think of this as just a start in several more activities similar to this. But this is born from obviously there has been already initial activities to put to start up the surf NEMO models and hydrodynamic models here in the Philippines. And the goal is really, as you say, that you have easily transferable models to different areas in the country and across different scales that can be used for a variety of applications. So that's the long-term goal. And we're just really you started, and I think now it's a good time to really discuss what has been done already and get feedback, and then how we can proceed then with if there's any improvements to be made, of course, and new things to incorporate and to understand, and also start the training or enhancing capacity for people, the students, and also researchers that will be involved in involved already in the current, and also will be involved in the new programs that going forward. So I see this as more of a hello and introductions and building the partnership to apply these forecasting tools in the area and going forward. So I think that's it. And now just sharing what we have now.
Great, thank you so much, Aleta. So we can start with our first presentation, Introduction to Operational Forecasting by Nadia. Nadia, would you like to share your screen?
No, just disappeared.
Oh, maybe there's an internet connection. Maybe we can give it a few seconds. Hopefully she'll jump back.
Oh, Cha is also here. I think you've met her. We were in the, you remember, in Barcelona.
In Barcelona. Yeah, I think I remember that. Hi, Cha, how are you?
Oh, I'm muted. Oh, I'm good.
There you go. How is it going?
I'm outside Manila for field work, so but we have to start tomorrow, so I still have time to be in the workshop today.
That's nice. Thank you so much for joining. We're just waiting for oh, there it is. Okay, Nadia, hello. Do you want to maybe share your screen to start the first presentation?
I will share. Sorry, I had to leave Aletta for a second because we changed the door and I didn't know how to close the door anymore. So amazing. Okay, too many things happening. So let me share the screen. I should congratulate because you really are oceanographers. I see in the background a CTD with bottles, which is nice to see for a lab. Let me see, I have to take this away, that away. So
Yeah, sure.
congratulations. Anyway, so this is me again, some introduction, and then Rita and Francesco will give you more technical issues. We'll give you an explanation of more technical and scientific issues connected with operational forecasting. So I will try to show you where we are now. We have to start from this. It took about 40 years, as I said, to get to this stage. And now what we have to do is to take advantage of this. So we have the condition of the sea as good as it has been known, and it was known likely to be from 1 to 5 kilometer scale by routine services. And so these are the one that we run in Europe under the Copernicus, and these are some that are run by NOAA, some that are run by Jamstack, but they're not at the same level of development. So I'll show you an example of what we developed as a regional operational oceanographic system. A regional operational oceanographic system normally is needed, but I will show you can also do without. And maybe this is the case for our work in CoastPredict. And then I will tell you about coastal forecasting, which is nesting into global or regional operational products. At this time, the best practices are present for both cases. And then I will show you one modern way to use this coastal forecasting for asking interesting questions for coastal resilience. So this is the system that I was referring to, the 1 to 5 kilometer scale, which is fully open access, available with a certain standard that normally is not for final users. It's not normally, it is not for final users. This service has been developed for intermediate users, which means the people like you who know about ocean and but maybe they need to learn some more about formats, metadata, NetCDF, and so on and so on. Anyway, so we in this service we have observations which are the real-time and also some historical. Well, we are not very good in historical, in my opinion. We have something better, which is the World Ocean Atlas and the World Ocean data set, which is better. But anyway, we also have this. We have analysis, which is really the key product for us, forecast, and reanalysis, also a key product for part of the applications. We go now from about 30 years, not 45. We have only few products in regional areas to 45. Mainly we start from the satellite era, which is satellite altimetry era, that is 1992. Okay, so that's the start of operational oceanography. It is altimetry. So currents, we give current, temperature, but also sea ice and some air sea, very limited because of unaccomplished agreements with the Met offices, and then biogeochemistry. Okay, so lower trophic level biogeochemistry. So we're mainly concerned with, really up to phytoplankton. So discover, view, and download. You can find here, and you will have a master person telling you, the Rita Lecci, on different protocols that we have for discovering, downloading, and she will also show you some of the tools that she has put together for you. So let me show you an example of what I think are successful regional system. It's clear that this is a perfect regional system because it is a semi-enclosed seas, but a bit less complicated than what you have in the Philippines, meaning as a Southeast Sea, sorry, South Asian Sea. So we have only two entries. One is here, and the other one is in the Dardanelles with the Sea of Marmara Sea. So much, much less complicated. And but it was enough to take us to, be busy for 20 years to try to develop. So now we are at the level of 1/24 of a degree, which is about 3 kilometers, going from the 7 kilometers of the global model, which is a good factor. We have much higher resolution in vertical, which is a key, 140 levels. We are coupled one way with waves and with pelagic biogeochemistry. That was our aim from the beginning, was not to rush a wave with the currents and tides, but have all the other parts to come with us. That means waves and pelagic biogeochemistry. So we could have gone much farther into the downscaling with the 1/24 and going to 1/36 and so on. But that would have left waves and pelagic biogeochemistry far behind. And so this is another thing that needs to be considered. Okay, so to show you that what is regional predictions goal is to have a continuous improvement of the quality at the highest resolution. And here we show typically an improvement between a consolidated system. You see the red one. Okay, so here we see a root mean square error, which is given by the square and the square root of the difference between the model and the observations along the track of the satellite. It is given in centimeters, and which is quite a good number, the one you see here. Normally in global models, you go to 10 centimeters. So we are here 3. That's the kind of improvement that we get with a regional model. And then you see here the improvement within the regional model. That is the red one is a system that we have been running. Oh, this is wrong. Sorry, let me try to see. Okay, there. Yeah, 2029 in the future. So I just said the past. That can be, yeah. Okay, that's 2019. That's much better. Okay, so this is the old system. And then in 2020, we updated the system to do better. And in fact, it does better. But the improvement, you see, starts to be 10%. And that's already quite an improvement. It's quite an improvement. Improving 10% the root mean square errors is something that requires lots of attention. Okay, so this is the other thing. After you improve, sort of say, I get something reasonable, then from that point on, it takes years and constant attention to the different components. And well, we developed some best practice, which we like to, make available to everybody. And which is, how to do this judgment. And we will write soon a paper on best practices for this. Okay, but you have already a state-of-the-art paper, which accounts for the system as it was up to 2019, I believe. Okay. So the coastal ocean, let me take this, sorry. Okay, so the coastal ocean here, this is an example of nesting into global predictions. This is what gave us the understanding that we can do it without going through, we can arrive at the coast without going through regional. So it has to be done properly, but you can probably do it. Okay, so let's see. For this area, this is a difficult area. So we went in a very difficult area. That was work done with Georgia Tech, a PhD student. And we were trying to look for skill in coastal storm surge. Believe it or not, it's still very low, the skill by NOAA systems. And we think we know why. And so we tried. So the other thing is that we had a lot of observations, as you see here, from citizen science sensors that allowed us to validate the model in a way that would not have been possible before, only with the NOAA tide gauge. Which are also listed here, but too small maybe. So we have this very small area. We have a hurricane arriving on top of it, which I guess your Manila accident also had some kind of very large storm coming over. And we are asking, can we do a good sea level storm surge forecast? So this is the result. The result is this is our model, the red one. We don't show the global model because it's, it was different. And in any case, it was necessary to be nested in a global model. And so our model instead does quite well. And this is, 3 meter. So, I mean, doesn't, sorry, Giovanni, Giovanni, tell me. Il link è su CoastPredict web. Ok? Grazie. Okay, so I invited Giovanni to discuss with you the Manila forecast for the oil spill, which we gave to Aletta. Okay, so now here we are here, and now what can we say? What is the key issue here that we get such a good forecast? Okay, so we went. This is tides. Naturally, you see there are tides, and in addition, there is storm surge. Okay, so we detided our time series. This is going from October 5 here, and I guess here is October, so it's 1, 2, 3, 4, 5, 6, so October 11. And so we detided and we extracted the total surge, okay? So then we wanted to show what it means to do coastal forecasting. And this is properly, and this is what it means. But coastal forecasting being nested, it means the blue curve. You see, the blue curve is very close to the total surge. And this one, it has only the sea level from offshore. Now, clearly, this is a very special condition. We have the Gulf Stream offshore, this area here. We have Gulf Stream. Okay, so I mean, this is a very important current system in the ocean. But this hurricane is capable of changing the position of the Gulf Stream because it's so strong. And so the being changed that position of the Gulf Stream, it changes the coast. It does. And so we show here in the blue curve, the sea level due to the changes in the Gulf Stream, which we call offshore, the offshore, because the Gulf Stream is offshore, gives us 2/3 of the signal. Without that 2/3, we will not be able to do properly the storm surge. And this happens in many areas of the world ocean. In any case, even if it happens in few of them, the few of them give us the direction. The direction is you need to nest properly into offshore flow fields. The red is instead due to the local hurricane winds. When the hurricane arrives on that coastal area and then the winds are felt, it gives the remaining 1/3. Okay, so this is, you can find a paper. It was a thesis by Park in coastal engineering, and it's 2022. So this gives us the idea of why we need to nest. There is no other way, no other possibility, because even one time this happens and a disastrous event happens and it comes from the offshore, we have to have a model that is capable to deal with that issue. Okay, so this is another system that we developed in Italy for our coastal. This is Italy here. It's not very visible. This is North Africa, and that's part of the Balkans and Europe. Okay, so here we show, and we developed this coastal model. This is another, you haven't been using this coastal model yet, which is the SHIFEM part of SURF. But we should soon have you use this kind of model, because this is really the coastal model. Okay, so then we go, and the first thing that we do, are we improving? So we see here observations in, one part of this coastal area. We see here what a regional system, what is called the CMCC, the blue curve, does. This is temperature on the abscissa, and we have depth. So this is a profile of observations. We see what, we were off like half a degree from observations, and now we are 0.2 degrees from the observations, and we actually capture the whole profile because the coastal model is going to the right depth. The basin scale model doesn't, because it doesn't go into the details of the bathymetry that we care about. I mean, a coast that is 20-meter deep or 10-meter deep is very different, okay? And this is the other big difference, that our coastal model has tides and is actually very good in doing tides. So observations are the dots. This is time versus sea level in meters. And so the dots are observations. The red is our local model, this model here, nested. And this is the sea level from the regional model, because at that point, the regional model did not have tides. Okay, now global models yet don't have tides. But here we show that if we use a region coastal model with tides, we do quite well, because tides most of the time are linearly superimposed to the sea level, to the storm surge sea level, and there are very few nonlinear effects. And in any case, we should have the tides in the global models, but they will arrive with the development in the years. In any case, we don't have to wait to have tides in our coastal model. We can have tides already in the coastal model through the coastal model. Okay, then the other very important thing, this is another area of major interest for Italy. It is a delta. It starts to be a bit complicated, like the Philippines. We have here a major river branch and many other branches. You don't see it, but this is like, it's a real delta with a lot of branches, the river, and we have bays where I will show you we do clam farming, and I will show you this model, how important it is to be used to choose clam farming solutions. Okay, so this is one way that we have to start is, where are the uncertainties in this modeling? And this is this model. Okay, it's another model. Again, it is a Schleifen model, because we now know we have to use these models. We need to use the unstructured grid models for the coast. Okay, so but it's good that you started with Surf Nemo, but this is the next step that we need to undertake. So especially in your Philippines archipelago, that is so complicated. So you see now we have a complicated archipelago here, and we asked ourselves, how do I know uncertainties? So we did different nesting choices. We choose different products. We take different atmospheric forcing. We take different rivers, uncertainties, and so on. And we run an ensemble that will tell us how uncertainty is. But not only that, where is the maximum uncertainty? In this case, I'll give you the solution. We published a paper in 2023 in weather forecasting. The major uncertainty in such a domain with such a structure is given by the initial condition from and the lateral boundary condition from the nesting model, even more than atmospheric forcing. It may seem atmospheric forcing, but it's not. The major uncertainty is due to this. But let me show you one other important issue here. We have observations, which are the dashed lines. This is time, talking about 2020, November 2020, from 11th of November 2020 to 12. So we see 1 day growth. This was a storm surge in 1 day. We concentrated on that. And so we see the data, okay, the observations of sea level. And again, this is sea level as a function in meters. And so sea level. And then we see here different curves. The green one is one of the experiments that we did. We even overshoot. So we even go higher. We shouldn't be surprised. Some model choices gives us an overshooting. We don't like that. As modelers, we don't like overshooting. We like undershooting, and then we like to find remedies to that undershooting. And so this one is, if you take ensemble member, so we get over undershooting, so we get less sea level than we need. But then if we do a smart weighted ensemble mean, it is the orange curve. We fit perfectly. Because not all our choices of nesting are relevant. They have been taken. So when we do a weighted ensemble mean, we weight the likelihood of a certain choice. And then we get the right result. Okay, so I conclude by showing you two examples of digital twin done with these models. So this is the same model that I've shown you now, where we understood the uncertainty. And this is the bay where whole clam farming of Italy, 90% of clam farming is done in this bay, which is a very delicate bay. It's an estuarine bay with a lot of, this is a river, and there are a lot of channels coming from the river to the bay. And then there is another river here that is not very visible, but has a lot of influx. And the people regulate that influx of water, okay? But they do it without understanding what is the effect on the health of the system here for clam farming. So we published this. They asked us to find out if a modified bathymetry would ameliorate the clam farming conditions. They had elaborated in the years, the farmers, some health index for the for the clams, which are related to salt, the saltiness of the sea, of the bay, and the also temperature range, optimal temperature range, and so. And so we were asked to see if they would change the entrance to this bay, would the conditions be better? And so here's the results. So with respect to this health index, which I told you about, we should take that for granted. This is present condition health index, means high health conditions near the mouth, because as you know, in any estuarine bay, the problem of the oxygen is actually coming from outside, is from the under the lower layer flow that enters the bay. So here is the opening, and these are the two channels that bring good conditions together with salt, oxygen and salt into the bay. So the health index is high in this area, is very low in these areas, which terrorizes the people. And so we went, we took our model, we changed the bathymetry, and then we saw what was the improvement. If I would dig, I would remove and make it deeper this channel, and you get an improvement of 10%. For us, it was, a great improvement. The people were expecting, 100% improvement of the health index. That's not the case. That's not the case. The circulation is complicated. And they were expecting to have an improvement everywhere. But no, in opening this part, you would get this due to the circulation of the bay. And then the other one is another change, which was very surprising to them, is that you get a good improvement, was another change in the morphology. You get a good improvement in this area, but you get opposite, a deterioration of the health index inside this very specific structure of the coast, which is called a scanno. It's a morphological structure that is built by sediment deposition along the years. So, okay, so we now know. So we said, don't cut here. If you want to cut here, you're gonna get this kind of improvement. Okay. So last one is the most common kind of digital twin for nature-based solution case. So we took, the question was seagrass meadows capable of attenuating waves. We took our seagrass, that is Zostera marina, and we put it in our model, which is also available. And we determined the seagrass belt that was needed. And we showed the great reduction with vegetation. This is for year 2011, but we can do for others. Now, this is a bit of an overestimate of the attenuation because our vegetation at that time, we did this experiments in 2020, 2021, was not flexible. Now it's flexible and still there is an attenuation, which is not like in this case. For example, here you see, we have 80% attenuation, 80% attenuation. That's too much. When you get flexibility, you get 50% only, which is a big number, 50%. Okay, so final considerations. Operational oceanography at global and regional scale started the continuous improvement of accuracy at about 5 kilometer scales, 1 to 5 kilometer scale. And we should take advantage of that. We can start from the global in the Philippines. Coastal ocean forecasting best practices are based on limited area, nested models into global or regional operational oceanography products. There is no alternative. So calibration, validation, and uncertainties estimation is required with local observational data sets, which makes the work difficult because you have also to provide the data. You have seen in our coastal areas in Italy and also in US, we had the specific data sets. And actually they are now operational, but you need to have an observational strategy. And then digital twins are key element to solutions for coastal resilience and a sustainable blue economy, as I tried to show you. And these digital twins are done with your best calibrated models in the coastal area. And they will be very effective if you do so. Okay, sorry, I took as usual more time. Questions? Are there questions now? Or we can shift at the end. I will make this available on the web naturally.
Thank you so much, Nadia. Does anybody have any questions or should we move on to the next presentation? Okay. So introduction to SERV. Francesco, would you mind sharing your screen then? Thank you so much, Nadia, again.
Okay, let's share, condividi. Can you see my screen?
Yes.
Yes, we can see it.
So I will start with an introduction of the SURF platform, and then after the break, I will present also a case study that I did days ago, implementing a resolution model in the Philippine archipelago. So, why we build this platform? So just an introduction and motivation of the platform. So SURF means a structured and unstructured grid relocatable ocean platform for forecasting. Is a platform that we design to be user-friendly, which will allow the user, even user that are limited technical expertise, to implement an high resolution model in any region of a large-scale ocean forecasting system. So facilitating this implementation. The platform is an open source package, and we distribute using a portable virtualization technology, now virtual machine, but also soon will be also available container, both Docker and Singularity, that will enable user to perform this limited area ocean forecast on any commercially available personal computer or laptop, also cloud, also supercomputer. So in this way, we can make advanced ocean forecast accessible to a wider audience. We build also the platform to also meet the needs of coastal community. A common request during several marine and coastal community action is for high spatial resolution ocean field. Action like support emerging response to extreme weather event and natural hazard, such as storm surge, reinforce the framework of maritime navigation safety, also minimize risks in coastal area after an oil spill. In all these situations, it's very important to have a good quality field of our temperature, salinity, and current that are well represented the process of the area of interest. Why the increasing the resolution is important? So as we know, when in numerical modeling, we define a numerical grid where we want to represent processes and scales. So we can explicitly resolve scale bigger than effective grid resolution. These, for example, are the coarse resolution grid, our parent model, and then these green line are the high resolution grid. And there are many small scale process, the unresolved that we call unresolved process that occur on length scale that cannot be adequately resolved on the computational mesh. For example, this scale, this structure cannot be resolved by the coarse resolution grid. So the idea is that model with higher spatial resolution simulation, spatial resolution simulate more turbulent ocean dynamics. So are able to resolve more portion of the ocean synectic spectrum. So the resolution models are essential for simulating processes at spatial temporal scale that are too small to be accurately resolved by global and regional coastal resolution model. A common approach are the dynamic downscale methodology, where limited area nesting model are based on the information of a coarse resolution model, which have many advantages, like finite scale response, able to deal with complex coastline geometry, and able to implement in the limited area a resolution model with a reasonable cost, computational cost. Obviously, for all these action that we want to support, it's important to have a tool that is relocatable, so able to easily deploy this high resolution nesting model in any choice region of interest in the world. So yeah, for all these reasons, we build in the last 7-8 years this platform that, as I said, incorporate post-process tool to facilitate the implementation of the high resolution model. As I said, it's distributed using high portable virtualization technology. The platform include approach based on multiple nesting with structured model NeMo, and also cross-scale seamless modeling with the unstructured grid model Schleifen. We have implemented already in many areas of the world for the different research topic. These are all the areas that we implement. How is working? To set up the downscale experiment, the user must specify the value of the input model parameter using this configuration file that has a JSON format. Oh, exchange it, okay. And then automatically after decided the data source, so the bathymetry, which are the initial condition for the course resolution model, lateral boundary condition, atmospheric forcing, tidal forcing. Automatically the model will generate the child mesh mask, so the mesh mask at high resolution. Then we'll pre-processing all the data, all the source data, interpolated the data on this grid. And then they will trigger the ocean simulation, NeMo or Schleifen. And then we will get the resolution model. After that, many also tool that you can use to visualize the input, remapping output, also compare the parent versus the child, also validate the model against observation. You can find more information on the website. So this is the website where there are information of the repository, gallery of some video, animation, image that we have produced. We have to add more. Some tutorial where you can step by step install all the package and test all the functionality of the platform. Then there is a documentation important, both from the NeMo and the Schleifen. So, and also you can download the package in this section where you will find also some case study where you can start to test the platform and then adapt this configuration model setup for your case of interest. Okay. So we are currently working on the next version. So in the end of the year there will be a new version where we also will start to use also container if you want also to deploy your model on a cloud or on a supercomputer will be also easy to do with that. Okay. That's all for now. And then after the break, I will present this experiment that I did with Source NeMo in the Philippine archipelago area.
Thank you so much, Francesco. Nadia has a question.
Yeah.
Yes, thank you, Francesco. So I just wanted to make sure you please stay on data flow. That's important. If you could remain on that.
Which?
Data flow.
Data flow, yeah.
Yeah, this one. Just wanted to be sure. So we propose data sources. Clearly, I mean, I guess, you know, you are already expert of this. We propose some data sources, and we recommend that we start from these data sources to start playing with surf and so. But clearly, some of these data sources, when things become more mature, will change, especially the atmospheric forcing, which we will discuss with Rita soon, and maybe the bathymetry, which is rather important. So we gave you we give, not you in particular, we give some of the choices that allow you to in our opinion, if done properly, if SURF is done properly, would allow you to show advantage in your limited area modeling, but is not, you know, these are not the final one. The input data sources can be much better. You can choose your own coastline, for example. So I just wanted to be sure that, you know, this is the beginning of the way to do. And clearly atmospheric forcing is one of the weakest parts of the whole story, which we will try to overcome with you. We will try to overcome in the next months and even earlier, but it's, you know, that depends on planetary agreements. I call them planetary agreements with the atmospheric community. And since they do not have an open and free policy, except for NOAA, that is difficult. Okay, so we will offer you now something different. There are so more than lateral open boundary conditions, I would say, an initial condition that we should concentrate on you know, bathymetry eventually in the next improvements of your modeling. But you know, that's the part that we will discuss in maybe the next course. Is another level of today's is an initial discussion. So one more thing I wanted to say, yeah. So the exercise that Francesco will show you later, it's something that we offer to you. It was done by, you know, Francesco, who is an expert, and offers some solutions that are slightly different from the one that you have used, but that are, you know, probably the next step with respect to what you have. So it's something that we will offer to you to be used in comparison to your implementation. Is that correct, Francesco?
Yes, I took some choice, and then we will share, and then we will compare with your configuration, and then we can discuss. Yeah.
What did you choose as atmospheric forcing?
Now, for example, this we are using NCEP. NCEP, one
Which is
quarter.
already the one that will solve your present problem.
Yeah.
Yeah. Okay. Just wanted to say that we should really thank Francesco, who did this exercise. Yeah, that is important. Yeah. Other questions on this presentation?
Okay, thank you so much, Nadia, for your feedback, and thank you so much, Francesco, for this presentation. So again, any questions so far from the participants? If not, then maybe we can move to the next presentation by Rita.
Yes, thank you, Ariba. So I'm going to share the screen.
Thank you.
And please let me know if you can see it.
Yes, we can see it.
Okay, good. So actually, Nadia introduced a little the topic of this presentation that you can see here on the first slide. So this presentation will support SURF, providing information on the upstream data needed to let SURF work. In particular, we will discuss about ocean and atmospheric forcing. Okay. Not only ocean atmospheric forcing, because SURF to work needs also the bathymetry, we already mentioned it, and the tides. So let's go through each input data and to provide more information to describe them and how to get them. I would like to inform you that for each input data, I'll share this, the presentation that I'm presenting now. And into the presentation, you will find all the links to obtain the data. So starting from the bathymetry, you see here there's the link. The bathymetry used by SURF is JEBCO. The bathymetry is an essential field that describes the ocean depths relative to the sea level. It provides a detailed description of the topographical and coastal feature at the seafloor and contributing in determining the main circulation pattern and dynamics. So SURF implements specific interface with the JEBCO, the General Bathymetric Chart of the Ocean. And in this picture, you can appreciate the most updated bathymetric chart available at these the website at 30 seconds horizontal resolution. In going on this link, you can select the area of interest and download the bathymetry only for that area. So you have not to download the global ocean if you are interested only to a specific part of it. Then, concerning the atmospheric forcing, actually SURF has two available interfaces. We mentioned NCEP, that is the global forecasting system running at NOAA in USA. The spatial resolution is 0.25, and here I reported the link to directly download the data. So just to let you know, it's for free. You can go directly on the website and download the data, or through the web interface, and you will see later on, or through a script you can download locally on your machine using scripting procedures. For each day, for each production day, and you will have 4 different production, 4 different base time. One at 00, so midnight, then 06, then midday, and 18. And you will have all the data, but let's see, all this information are reported in the coming slides.
Sorry, Rita.
Yes.
Just wanted to say, these are 4 forecasts start time are actually, complete, it is the standard for atmospheric forecasting centers. Actually, you have even 3 hours start times. So now I just wanted to say, this is not something, this is normal for the level of forecasting centers that we have in the global world. So ECMWF, for example, has a forecast started every 3 hours of the day for the next 14 days, and then the lead time is 14 days. So, we are taking NCEP, and they give only every 6 hours, but they also do every 3 hours forecast restart, because the atmosphere is very variable on the hourly time scales. And so already meteorology does reinitialization every 3 hours. Just wanted to be sure this is not a spatial feature, sort of speaking, is something very common in global operational meteorological forecasting systems. Just wanted to add.
Nadia, I would like to compliment saying that these are the base time, not the frequency of the data, because the frequency of the data, as you are stressing, are over 1 hour, 3 hours, and 6 hours also in this case. I will show in the next slides. It means this link means that every day you will have 4 different production. Yes. And for each production, you will have the temporal frequency of 1 hour, 3 hours, and 6 hours for the output.
Yeah.
These are the base time. Okay.
Yeah. In oceanography, we don't use so much. You use the proper way that meteorologists use, but I think that I use the word to be more initial time of the atmospheric forecast, 00, 06, 12, 18. So these are their reinitialization time for the meteorology, and then the frequency of the forecast is clearly different. The frequency of the output of the forecast is the one that you are talking about, right?
Exactly. Yeah.
Okay.
So, okay, and as said, there's another provider of data, but as Nadia said, they provide data only under specific agreement. So the data they provide has the spatial resolution of 0.1 degree, globally speaking, both for analysis and forecast. But let's go more in details into GFS data. On the right side here, you can see the domain covered by this system for some relevant variables. For example, here on the right side, now you can see the 2-meter temperature and overlaid there's the arrows, the fields of the winds at 30 meters. Or other variables available are, for example, the total cloud cover, and you can easily check the distribution of the clouds, and there's the label bar with all the values. Now it's not really clear because it's little, but all these information are available for free on the web. And there is another plot for rain and mean sea level pressure overlaid. But let's provide more information about those data. On the left side here, you see an animation for the total cloud cover. But let me say that, so GFS is the cornerstone of NSEP suite of numerical guidance. So is the system providing global atmospheric and also wave predictions at 0.25 degree spatial resolution. So there's the data simulation provided by the Global Data Simulation System, called GDAS, the acronym, which run a 4D hybrid ensemble variational data simulation scheme, producing the initial conditions for the forecast of GFS. As said, the GFS run 4 times a day, 0, 0, 6, 12, and 18, producing forecasts up to 16 days in advance. It produces data not only at the surface, but for all the levels of the atmosphere. So in vertical, the model provides output over 127 vertical layers. And as mentioned, the output is a different temporal resolution. For the first 120 hours, the temporal resolution is 1 hour. And then from all the others forecast, so from the day 5 to 16, the temporal resolution decreased to 3 hours. All the data are provided through the GRIB format, and the output are verified, and the verification is available for free on the web. Here, once provided this presentation, clicking on each link, you can access directly to the web interface explaining what I'm reporting now. Here, these slides focus on Philippines area because there's an important tool provided by NSEP called GRIB filter. So this allows you to not download the whole global data, but only to select the variable and the area of interest. So in our case, this is the area selected, and below I'm showing you the output as obtained through this simple command that you can run on your machine. In particular, this is for the 2-meter air temperature in Kelvin degrees. This is a forecast for 29 of July, 18 UTC, produced with the run of midday of the same day. So this is the label bar. I said this is in Kelvin, so you can easily understand the values. So you can retrieve the data of your interest or going directly on the web server. You can enter the parameters as the bounding box, so the latitude and the longitude and the specific variables you need. And then you can just click on download, and you can do this action directly through the web interface. Otherwise, you can download the data using a simple command as wget or curl, and just reporting close to this command a command like this. I would like not to go into the details, but I'm reported in bold that this is an example of the data visualized on your left side. Actually, what this command is saying is that starting from this file, that is the forecast for the time 18 UTC, reporting all the variables for the whole global. You would like to have only the temperature variable. That this is the name for I identify the variable in the list of GFS GFS provides. Then you would like to have the temperature only at the 2 meters above the ground, and for these bounding boxes, for this sub-region. So you have to put the bounding box, the top latitude, and here is 16 degrees north, or the bottom latitude is 8 in this case. And for the longitude, the left longitude, so 118, and the right longitude 128. And if you run this command on your computer, then you will obtain exactly the image, the data to create this visualization. And the data is in grid format, and it's easily manageable, but if you want, you can also convert it to NetCDF if your activity needs NetCDF data. So let's go just a fast overview on the other atmospheric forcing, ACNWF. Here I have reported that, as said, this is not free. It provides data only under specific agreement. So here on the left side, you will see some fields visualized. And then this is, as said before, a data set with a resolution of 0.1 degrees. It's called IRES. The description here reports again 4 forecast runs per day with hourly time steps until step number 9, and then the temporal resolution decrease from 3 hours and to 6 hours to cover 10 days of forecast. Also in this case, the data are provided as a GRIB format. The other important upstream data used by SURF is the tides. You can obtain all the data needed through this link. So you can connect to TPXO that provides a series of fully global models of ocean tides. And in particular, these models were obtained through OTIS. OTIS is the name of the software. Here you have all the references to retrieve more information about these data, how they are created. In particular, these models includes the 4-8 primary harmonic constituents, M2, S2, N2, K2, K1, O1, P1, and Q1, On the right side, you will see an example of the constituent M2. The current version, so the most updated one, is a TPXO9. The data that are provided are in different format. It could be binary or NetCDF formats. The binary format can be read using the software provided by TypeXO, that is OTPS, or also with MATLAB package, you can read the binary format. With the package provided using Fortran 19, the users can extract the harmonic of interest for the area of interest, predict tide at given times and locations, and extract a local multi-constituent model from set of global TPXO Atlas single constituent model files for any rectangular local area. On the right side, you will see an animation for, this is the tides. So let's go now to another very important upstream data for surf, because this is the parent model, the oceanographic parent model. Nadia already mentioned it. It's a model provided through Copernicus Marine Service and run by Mercator Ocean. If you go on Copernicus Marine Service, you will find this product covering the global ocean with this name. Again, if you click on it, you will see now, I'm not clicking, but there's the link, the direct link to arrive on the description page of the data of this data set, and you can download it. As said, surf includes multiple nesting and starts from these data sets, and then surf will reach an higher resolution, horizontal resolution, also a few hundred meters. So in these slides, you are just visualizing some fields produced by the global forecasting system. This is the sea water velocity field. You can see the arrows, and underneath there are as shaded the intensity of the currents. Then the seawater potential temperature. This is for a specific date. And then the seawater salinity and the sea surface height. But let's provide more information about this product. So this product is so the model, the system runs with a daily cycle instead of only one day of the week, the first day. The model runs a weekly cycle. In the next slide, we will see what does this means. About the information on the models, so it's NEMO 3.6, the version of the physical model. Then the model includes also the sea ice component, and the name of the model uses LIM3. And the frequency and resolution of the atmospheric forcing is I'm sorry, no, this is an error, because the frequency of the output is no, sorry, no, it's not an error. Okay, so the atmospheric forcing here used by this model is for 1 hour for the first 90 time steps, then it becomes 3 hours, and then 6 hours. And the output produced, reported in the next slides, covers 10 days in the future. These models, the system also use data simulation, and here are reported sad information on the simulation, data simulation scheme used, and the observation that are assimilated by the system. So they are not only satellite observation that are SST, so the sea surface temperature, the sea level anomaly, and the sea ice concentration, but also temperature and salinity profiles from in situ platforms. As mentioned, temporal resolution of the output is daily and monthly. The temporal coverage, so what you will have going on Copernicus web face is the time series covering -2 years plus 10 days. So you will have a time series covering the last 2 years, and then there are the 10 days of forecast that are refreshed every day. Some information about the vertical levels and the spatial resolution of the model. So the spatial resolution is 1/12 degree. And for the vertical levels, there are 50 vertical levels ranging from 0, the surface, to the wall water column till 5,500 meters. The output, the variables provided by the systems from the top to the bottom, covering the global ocean, are the one listed here. So temperature, salinity, currents, sea level, mixed layer depth, and the ice parameters. So all these variables are provided to a temporal resolution of daily and monthly. But then there are also hourly data available, but only for these fields reported in bold. So sea level height, temperature, and currents. This is the schema on how the system works. As said before, there is a daily cycle, and then once a week, there's a weekly cycle. What does it mean? The weekly cycle is reported here, where you see the different colors, one close the others, orange, yellow, gray, and blue. And this it's first day of each week. Every day, the forecast delivered the previous day is, you see here, forecasts are in blue, are overwritten by a simulation that is in gray, arriving till Thursday, where the system goes back to the past for 2 weeks, providing analysis. Analyses are subdivided into 2 main blocks, the orange one and the yellow one. The orange one, so the first week of a simulation in the past, is considered the best quality analysis. And here reported here, you can see on the right side, the accuracy, the increasing accuracy of the output data provided by this model. So the orange one is the best analysis. Then there is the yellow one is the near real-time analysis, then the simulation, and then the 10 days forecast. So every week on Thursday, the system is running back of 2 weeks, then it's able to restart from the best restart available for that specific day of the week. And then after 1 week, this process applies again. So every day, these data are provided there's a target delivery time. This target delivery time is midday for daily and hourly datasets. Then here there are more information on how the analysis provided on first day are subdivided in best analysis and the near real-time analysis. But anyway, all this information are available and described into the 2 main documents that Copernicus provides, that are, the first one is the PUM. PUM stands for Product User Manual. So there are described all the data, the format of the data, and the variables included into the data. And then there's the QUID, that is the quality information document. Let's see some information reported into the QUID. Just as an example, I will not go into the details of this, but if you go again on the Copernicus Marine Service for this specific product, if you check the evaluation, so the QUID document, you will have information about the comparison of the output of produced by this model with respect to the observation. And so you can see how the model is performing with respect to the observation. So on the left side, there are maps. This is the difference analysis versus observation for temperature, and it's this map. And below is the map of the root mean square error. On the right side, I'm presenting you some validation done for specific area of the world. So being this a global ocean product, there are evaluation done not only globally as average, but also in some specific area of the world. And I just selected 3 of them that could be of interest. And you will see here the again for temperature, this kind of analysis, a vertical profile, the difference of the output of the model with respect to the observation. And the percentiles you can see here. So the mean difference is reported in light blue. This is the line here close over the 0. For the tropical band, so tropical Pacific Ocean, tropical Atlantic Ocean, and the Indian Ocean. So temperature is not the only variable analyzed and validated by for this system. You will find others. This is another example, similar for as temperature, but for salinity. So again, on the left side, you will see the difference of the observation against the analysis of the model for salinity and the root mean square error. And on the right side, the vertical profiles. The vertical profiles, both for salinity and temperature in this case, are for this year, 2019. But every time there's a new version of the system, actually it happens once a year, because it's always the state of the art of the model. So if there are improvements, also the output are improved, and the analyses are updated with the most recent ones. So these ones are referred to 2019. Not only the open ocean, here we are in the Arctic region, and these maps are showing you the seasonal mean difference between the model and the observation for the sea ice temperature. So this is January, February, March, April, May, June, July, August, and September, and October, November, and December. And then the colors, if checking the label bar on the right side, is saying the difference computed between models and observation. Last but not least, the quality of this product is constantly monitored. So if you go on this link, you can find many metrics provided, not only for the historical output compared with the observation, but also for the forecast. In particular, here you see an image providing you for the global ocean where the tide gauges are available for a comparison with the model output. And but the information is provided not only against the in situ observation, but also against satellite observation. So I suggest you, if you would like to know more about this product, to check carefully this link that I provided. So this was the last slides. I know that it was a really fast presentation, but if you would like to, if you need support, please email me. This is my address. I'm available to support you. Thanks a lot.
Thank you so much, Rita. Thank you so much for the presentation. I think Nadia has a question. I saw her hand raised up.
But I see also the time we need to take a break.
Yeah, it's we're running a little behind schedule. So if nobody has any questions, maybe now we can take let's say a 15-minute break, and then we have 3 more presentations after the break. Let's aim to get back at 10:45-ish, if that's okay with everybody.
Yes, we
Sounds
should.
good. Okay. We'll see you in about 15 minutes then. Thanks again, guys. Thank you.
Yeah, I will add just only to add that I need to leave for another meeting, but I said I'm available offline. If you want to ask any question, please write me. Okay?
Thank you. Thank you, Rita.
Thank you. Thanks for
Thanks,
your attention. Bye.
Bye.
Welcome back, everyone. Hi. We can wait a few more minutes so that everybody's back.
Okay.
Okay, perfect. Welcome back, everyone. Once again, thank you so much for joining this limited area forecasting in the Philippines workshop organized by CoastPredict in collaboration with DCC-CR and CMCC. Once again, it's really nice to have you all here. Looks like most of the people are back, and maybe we can get back on track. We're running a little late, so I'm sorry, I know this was a short break, but let's get started again. The next presentation is by Aiko. Aiko, would you mind sharing your screen?
Okay. Let me just choose which screen can share. Oops. Application. Ito? Okay. Share. Can you see my screen?
Yes, we can.
Okay. You cannot. Okay. Wait. Let me just change. Wait lang, di ko nakikita. You cannot see it? I cannot see. Duplicate ko na lang. Yan. Okay. Sorry. Is that... Ayan. Oh. Okay. So, hi everyone. So I am Aiko del Rosario from the Marine Science Institute of the University of the Philippines, Diliman. So I will present the preliminary results we have from doing SurfNemo model. So here's a presentation titled Multi-Nested Models of the Philippines, Internal Seas, and the Visayan Sea. So a brief background. So we're doing Visayan Sea model for operational oceanography because it's an interesting part of the Philippines where being it a very small area, it contributes 13.46% of total fish harvest to the country. And we also find that year-long, we get a high chlorophyll A or primary productivity in the region. And with the findings of our colleague back in 2013, she found that there's a possibility that tidal resonance in the area could affect mixing within the water column that might be that might be the reason why it's productive in that region. So I present here the hydrodynamic model. Oops. Okay, it's loading. Can you see the slide? Ayan. Nag-load kasi. So
Yes, we can see very well.
So this is the model that I worked with. So for the bathymetry, I used Gemco 2014, the one that's inside the virtual box VM. And then I used ECMWF ERA 5 for the atmospheric forcing, TPX-08 Atlas for tides. And then for the initial and boundary conditions, I used the Global Ocean Physics Analysis and Forecast from Copernicus Marine Service. So I have started with 3 days for the further model. So you can see the red box, that is the further model. And then that is the one that I will nest from the global data set. And then the yellow box is the nested model of the Visayan Sea. And then the period is from May 7 to May 12, 2024. And I have used the following time steps, 200 seconds for the fodder and 100 seconds for the child model. And both have 100 layers vertically. So I have downscaled the global model from 1/12 to 1/24 degrees for Philippine internal seas and 1/48 degrees for the Visayan Sea. And as you can see, we have a very high, very deep trench on the east side of the Philippines. So I changed that maximum depth to 8,500 models so that the model would run in SurfNemo.
Sorry, can I disturb you 1 second?
Yes.
Can you go back? Are you
Okay.
sure that you're doing the downscale from 112 CMAMs, or you're not downscaling from the 124?
Sorry. That's I need to correct that. I have nested the Visayan Sea from the Philippine Internal Sea Model.
Oh, good. That's
Okay,
good.
sorry.
That's
Um,
better. Yeah.
That's an error. I will change that later. But yeah, I time scaled from global to Philippine internal seas and then Visayan Sea.
Excellent.
Okay, so this is the parameters that I use. Paano ba ito may ililipat? Ayan. So I've used these parameters. I just followed the paper of Francesco on his work with multi-nested models, and these are the parameters that I've used, and I just followed the equations there to change the parameters for horizontal and vertical subgrid scale processes. And then this is the bottom friction. Yeah, these are the parameters for bottom friction and the time that I used. So I can send in these tables through email so that you can also check what I have done so far. So this is the father model that I have made for the Philippine internal seas. Is it loading?
Yeah.
Yeah.
We see.
Okay.
We see.
So you can see at the lower part of the animation, you can see that the Bohol jet is very strong. So that is a very prominent feature within the Philippine internal seas, and strong currents near San Bernardino Strait. So this one, strong currents here in San Bernardino Strait. And then here is strong currents there in Siargao area. And then we also have the Iligan Bay eddy. So this is also another feature that we always see when we're doing cruises. And then
Oh, can I ask you a question? Was that structure already present in CMAMs?
yes, Janelle actually, one of our students did her thesis on Bohol Sea. So she can also see that feature in Siemens.
Okay, good. I just wanted to be sure, because it's very difficult if the initial field has not that structure to construct it from scratch for the downscaling model. And it shows also that CMMS is a high quality model to start from. Yeah.
So next, oh wait, ano ba? Exit. Okay.
And how about the amplitude of the currents? Is that approximately correct? Because it looks like you have 1 meters per second currents somewhere there. Is that something that you know?
Yes. Actually, we find very high velocities near the areas where we expect it to be strong, especially in San Bernardino Strait.
Okay.
Yes.
So the order of magnitude is 1 meters per second is not 0.5.
Yes. So this one, sorry, it's very slow on my end. For the father model, I just used the post-processing script within Surf Nemo. And then it's so I just used it to present the post-process data. But when I look at I have currents more than 1 meter per second.
Yeah, it will be nice maybe to adjust the palette.
Okay.
To show sometimes that, where are the areas of large, but this is also a nice representation. Do you know how to change the palette, right?
Not yet.
Okay, good.
Okay.
Good, that we know.
Configuration 5. Oh, there is.
Yeah,
I will show later. Okay.
yeah, yeah. Okay. Yeah, so what I did for the nest model, since the post-processing script was not working properly, I just take out all the output data and then run it in MATLAB, since that's the one that I'm more comfortable using. So this one is for the nested model of the Visayan Sea. So we're getting, so I run it from May 7 to May 12. And we're getting very high, not very high, relatively high currents at the west side of the Philippines, of Visayan Sea. So this one between Masbate and Panay Island.
Yeah.
So we actually went there for a validation. So I will show you later how it looks like. And so far that's what we are observing, that we have very high currents in that area. So it's interesting to look at, since a lot of fisheries, a lot of boats go there to fish at night when we went there. So
You mean it's also dangerous?
yeah,
Because
and it's also dangerous.
yeah, because the 2 meters per second is very high.
Yeah.
Yeah.
So so this one is during flood tide. So the area where the topography changes from 0 to 0.25 meters to 50 meters has actually strong currents, and also during ebb tide. So we're still looking at the effect of tides in this area for further analysis. And then we went to Visayan Sea during that time. So May 7 to May 12, we did a cruise with a traditional bangka. So we hired a boat crew with their passenger boat, and then went around the Visayan Sea to measure currents using ADCP, and then we measured salinity and temperature with CTD, and then anemometer for wind. And then we went around the Visayan Sea with this location. We actually did not follow this one. We went up to Gigantes Islands to also check out how's the currents there for a research on scallops. So we also went there to get some data. And this is the tides during the cruise.
But you don't have any tide gauge? in the-
We're still processing it, but we now have access to tide gauge data until 2023. We're still requesting for a new set of data from NAMRIA, which is our national mapping agency. So I hope
Where
I
is
can.
it? Where is it in this map? Where is your tide gauge?
And so we have tide gauge data here in Bantayan.
Okay.
And here in Rojas, actually near Carles or near Rojas. And then I think we also have sa may ang tawag, so boss, Masbate. We also have some data from Masbate here, but I
Very
still
nice.
have to double check.
This is really nice. So it's
So we have yes.
it's important to check you know, a longer period of your downscaling. Like if you do few more days, I mean, we need to tell you how to do your runs in a concatenated way, what we call a concatenated way, so that you will be able to reconstruct a long time series of currents, sea level, and then compare with for calibration validation. Great. If you get this data, these are really important.
Thanks, Nadia. So I'm just gonna show some results that we got in the field. So here I've mentioned that we have strong currents at the west side of the Visayan Sea. So we also got that same result from ADCP. So I'm just presenting here the surface currents since I'm still processing the at depth currents. So we have very strong currents at the west side of Visayan Sea. When we went there, actually, it's very strong that we cannot sleep properly on the boat. So I think it's very consistent. The model was consistent with what we observed with the ground, and most of the sea surface currents that we get coincides with the movement of the winds at that time, which is mostly easterlies. And then I've also compared the modeled sea surface temperature and the sea surface temperature from our CTD at 0 to 5 meters. And we find that the western side is more warm compared to the other stations that we have. And then for salinity, so the northern part, we call this acid gulf on the northern part of the Visayan Sea. This one, we call it acid gulf. So that one is a little bit saltier compared to the other parts of the Visayan Sea.
Can I ask you, so
Yeah.
I see you're using the visualization tool, what is the name?
ODV.
ODV.
Yeah.
So, you know, but in order to really, so we need to do, in order to really compare with the model, there are two ways. The first, ODV is, you know, it's not really done for kind of synoptic data, is more done for historical data where more or less you have everywhere data and then you get a smooth picture. But for this, we have two ways. The first is, and I wanted to ask Francesco, don't we have the tool to compare with in situ data profiles available from SURF? We don't. We don't make it available, right, in a post-processing.
Actually, now in the current version, there are, but now in the last 1 year we upgrade all this validation procedure. But there are validation from with satellite, with the CTD, and perhaps
So, but
you need
where
to
are
add
they? Are they in the container or in the virtual machine?
in the virtual machine. So in the yeah, there are in the
Okay, so
cartridge.
normally what we do, Aiko, is that we bring the model on the exact position of the data. We compare for the closest time where the data was collected, because you know, the time variability of temperature is large, especially in shallow areas, and salinity too. So I think that to make a final conclusion, like the one I've shown you with profiles and so, we need to use that tool, which brings the model on the observations. Please notice that is always this way, not the other way. You never touch the observations that have much less error. So you interpolate the model into the observations.
Okay.
And that would give a better estimate of the error the model does. So, but you know, you have a wonderful data set now, and we can try many tools, and maybe you can you can send an email, Francesco, by advising how to use the tools that are available in the present SURF NEMO.
Okay.
Yeah. So yeah, very good. Yeah.
So yeah, so in conclusion, we have finally done nesting in Surf Nemo. So we did Philippine Internal Seas in Visayan Sea model. However, it also needs correct forcing. So we're still not sure whether we can use ECMWF for the atmospheric forcing. And then we have showed some agreement on sea surface variables, but we still have to validate it properly with the time, since we are limited to stations only. And we have to cross-check our model and observe profiles of current temperature and salinity. So lastly, I would like to say that we're having some issues with post-processing. So yeah, so that's the errors we're getting with the nested model. So I think we can discuss it later with Francesco and the team. Thank you.
Thank you so much, Aiko. Thanks a lot. Are there any more questions for Aiko?
Yeah, I have several. And so,
Go ahead, Nadia.
yeah, so first of all, let me congratulate you for having done already the two-step nesting, which, it's a crucial one. It's really using the power of surf to the maximum level. As I said, I would see also an evolution to use unstructured grid, but for the unstructured grid, we have just finished to put together a gridding tool that is easier to use, because the one that we have now, it's not, it's too troublesome for people to use. In any case, this is already a very good starting point. And so I would advise to go strongly into the verification part, but also start thinking, now we will talk about ECMWF in a second, but we start thinking about concatenating, so producing a concatenation of your 1 day simulations. They're not really forecast because you use atmospheric forcing that is ERA 5, and that's totally fine, but it's an analysis. And it is in the past, perfect. But what I would think is important, you have now a snapshot validation and you have to validate, but at the same time, you have to run more often your model, because the statistics is, we need to build a statistical understanding of the situation. And so what it would be nice is to use concatenating. So you should restart your model, your father and your child, every day for 3 days, and do the chain, and then concatenate. We call concatenate. We can write to you, I guess, a piece, a paper where we say how we would do. But that is also very important, that you see, for 2 months, for example, you should run the system for 2 months and reinitializing every day with the 3 days, and then inside doing the 1 day or 2, even better, with the child model, and then concatenate the output to get the best sequence. So 2 ways, 2 things, the validation and the concatenation to get you more statistics on the currents. For example, this strong current there, how often is there? Is it for 2 months is always there, or does it have a weakening? It will be important for the people, the user, to know. And for the last one, okay, so we advise that you start to use NSEP the way that already SURF allows you, and Francesco will show you in his implementation. At the same time, we are trying to get ECMWF because it is clearly much better. The resolution of the wind forcing and the rest of the forcing is much, much better. But for doing that, we need to meet with our Met Office and ask them to give we need a special agreement. And so we have done it other times. We're gonna do it for the global coast experiment for many areas, and we are checking with our Met Office how to do it at best. Our Met Office is supporting all the time our Italian initiatives, and we are going to first consult with them and then tell you what is the way forward for the ECMWF. Meantime, you don't have to wait. We have the NSAP. That's a very important resource. And Francesco will illustrate now, will give you a version of SURF where he uses NSAP. So you can see from JSON, from whatever file is required, how it is done.
Thanks, Nadia. Looking forward to Francesco's presentation.
Thank you, Nadia. Moving forward, if does anybody have any questions still now? Okay, so Francesco, the floor is yours.
Okay, so let me share my screen. Blah blah blah. Desktop, condividi. Okay. So this was a very fast implementation. I did the experiment Friday, but I have some results using this NOAA dataset and SEP as input data for the surface boundary condition. So these are the model setup. Oh, let me do it like this. Okay. Without entering the detail, just allora I performed a simulation of 10 days starting from 2 February 2024, so a few weeks ago. I'm doing downscaling from the CMEMS 112 degree global model global analysis forecast model product. So from 9 kilometers in the area of Philippine to 3 kilometers, so a grid ratio of 3. Then I'm using 100 level, vertical level. Then just focus on data and some specific numerical formulation. As ICO, I also use the data that are inside the platform JEBCO 14, but also recommend normally when I do the new experiment to also check the new dataset available on the JEBCO. So the format is the same. You can just extract the dataset in the area of interest and just change the link from the sort of dataset static link inside the platform to your input offline dataset that you will insert in the platform. Then, as initial boundary condition, as I said, I'm using the global CMEMS analysis forecast, daily mean. So I took the temperature, salinity, SSH, and the zonal and meridional velocity. Tidal forcing, elevation, west, east, and north transport for most of the energetic tidal harmonic from TPXO that we will use to correct the barotropic velocity at boundary as our parent model has not tides. And then here are the atmospheric forcing input field that we need that I took from NSEP, 1/4 degree, global analysis forecast, 6-hour frequency. And for this particular implementation, in IMO there are different bulk formula that use this input field in order to compute the moment, the flux of momentum, heat, and water. And for this downscale experiment, I'm using surf as an interface with this bulk formula, core bulk formula that need as input this list of variable.
Sorry, this is a JSON parameter. The core, you decided through JSON?
Yeah, in the JSON you can choose for now in JSON MFS and core bulk formula. And
Yeah.
according to the bulk formula, you will look for a specific variable. And
Yeah, that's okay. But it is a parameter inside JSON to
yes,
decide
yes,
about RC fluxes.
yes.
Okay. So it's
Just
not complicated.
no, just to change one number. So
You have to change a number in the JSON to change bulk formulas, which is a very complicated issue. But in this case, we have chosen to change them because when you go from a global data set, it should be the best should be to use these core bulk formula that are done for global models.
yeah, these are done also tested with the NCEP data, and so I choose this core bulk formula.
Okay.
And yeah, these are the list of variables that you need to download from the NCEP website, as Arita told, zonal meridional velocity.
But don't you have the script that you did it? How did you do it?
Yeah, this one is the script that Rita showed in the last presentation, how to take down the data from NCEP and convert in
Using the different variables.
yeah, take this data and convert from grid to an SDF and so on. However, now just
So it would be useful to have a script from you with different commands aligned. First, you download the wind components, and second, and so on, so that you have it, something, right?
Yeah. No, just a preview because also in the next version of SoftNemo, all
Yeah, but the next version is December. We have to work on.
No, yeah. Obviously now I will we will pass all the script in order to download the variable from NCEP and convert in the appropriate structure for the SoftNemo. Yes, and yeah. So these are the input data. And these are specific formulation that I use for this implementation. Packanosis Finati scheme, two band light penetration, Bilaplacian Pareto from tracer momentum, horizontal subscale physics, nonlinear friction.
Sorry, but this one, okay, but most important, why did you choose to start from July 2nd? What do you mean also you decided to start from July 2nd? You run only one run starting from July 2nd and going forward 10 days?
Yeah, I start from July 2nd. So I took the initial condition, daily mean from CMMS from July 2nd, and then I ran 10 days starting from that starting point.
Only one run.
Only one run, yeah, it's just one run.
Why? Yesterday we were talking about starting from July 24th, right? We were saying that at least you could cover the Manila accident.
Yeah, there was no time, Nadia, so I came back yesterday evening.
So this one is the one you did, you showed me yesterday too.
Yeah, this is one that I did Friday. So I did update with the new recent period. So these are from 2 to 12 of July 20.
Because just to tell you, the domain that Francesco has found contains the Manila. In your case, I see your domain does not contain Manila, the Manila Bay. But in the case of Francesco, this new domain contains Manila Bay.
Yeah. If needed, I can do also the new a new simulation with the recent period. Yeah, this is the domain. So the model domain covered the Western Pacific Ocean area. Between the Philippine Sea, South China, and the Sula Sea. More or less is 10 degree in the zonal direction and 8 degree in meridional direction. As I said, I downscale with the grid ratio of 3. So our child grid has 3 kilometer horizontal resolution. And it's a 10-day simulation period. Okay. Okay. So as usually, when I normally define the model domain, I check all of the parent model, the current, how they are, the structures in order to put the open boundary. So these are just to show the parent model. I'm using the global analysis forecast system as you are using, Aiko. Just reading some paper about this current structure. So in this area, you have this western workflow north equatorial current that is splitting into current, the Kuroshio that go to the north and Mindao that go to the south. So I want to take these two part of this branch inside our internal domain as internal solution. And then also these are a complicated system. This branch go inside the Luzon Strait and generate also this other jet. Also this one across the western coast of the Philippines. Yeah. So input bathymetry. So as you know, land boundary exert a strong control of ocean dynamic. So these are a very complicated topography bathymetry. So large archipelago with a lot of island, yeah, including mini between Iceland Strait and Seal. And there are these three deep water area. So the reach also this one I think 10,000 meters, so 10 kilometers. Just to appreciate also the bathymetry also. The last period I'm doing also this three visualization, just to see also. So here it is solo deep part. So this is all the thousand of island in the Philippine archipelago, very complex with all these strait and seal that will constrain your flow inside the Philippines, the slope, continental slope, and yeah, so this is very complex bathymetry. And using this 3 grid ration downscaling, we reach 3 kilometers. At this resolution, this is the mesh mask. Just I want to check if the old strait, the open strait from the Philippine Sea to all these strait are open enough in order to have a realistic inflow of water, if there is an inflow of water. So we can resolve the Manila Strait with this resolution 3 kilometers. So these are the entrances that is good resolved. Also, the strait is open. And we'll see also, for example, here, here there is a huge difference between the parent model that is almost close. You don't have, or you have just a little inflow of water, but with a right resolution, good resolution, you will see that the pattern dynamic will change in this strait, and so on. And yes, just showing the velocity, surface velocity.
This kind of plot will be very useful for you, Aiko, is having the parent, meaning the CMEMS in this case, model next to your first nesting.
Yeah.
Because you were pointing out to these strong velocities in this strait, but actually it was not present in the parent model.
Yeah.
So the parent model actually had a very, as we know, and very non-detailed bathymetry and not enough grid points to get the strait correct. That also means that your anticyclone that you were pointing out, is it an anticyclone or a cyclone?
Cyclone.
Yeah, I cannot see it. Is a cyclone? Is it a
Yeah,
cyclone?
it's a cyclone.
Cyclone. Your cyclone, it's not due to that inflow because it is present in the, as you were saying, in the sea, in the parent model, as you were saying. But that means that that cyclone is due to some local dynamics.
Yeah.
People might connect it to the flow, but it's not.
Okay.
Yeah. Yeah, this is a part of post-processing of surf, and I normally do this comparison where we compare the mean value, because I start with the daily mean of parent with the mean value of also the child. By default, surf output the hourly mean, and then we do daily mean. Yeah, these are very useful to check the how the array solution will capture more small scale dynamic pattern, how they change compared to the parent model. Yes.
Can I ask you, is this post-processing available one next to the other, or you constructed it?
No, it's available. They give you directly this. No. They give you this and then this, and then I make as a.
No, okay. They, who is they, since it is you?
No, sorry.
It
They
is.
are creating a list of plot for the parent, and then also a list of plot of a child
So
independent.
Aiko, can you produce plots for the parent, so-called, which is the Siemens? Did you try?
For the parent model,
Yeah.
yeah, I haven't, but we plot it for other papers that we do.
Okay. So,
Yeah.
but it's also important to have it. So you can use the scripting that you have available to plot also the parent.
Yeah.
No. It is important to look at the two of them. You already will know about a lot of oceanography by looking at the two different solutions.
Yeah.
Just I wanted to point out, so this is not, something, let's say, unimportant in comparison. It is a very important comparison because the parent model might have features that are realistic without having other features in it that people normally connect, but they are not connected. Okay, but let's go.
So
Sorry.
let's start the animation. So these are 10-day daily mean. So just check the difference between the parent and child. What we can see, the big structure are maintained, but we have very peculiar small scale dynamic pattern, especially near to the coast. Now I will zoom also in some area, but you can see also from this the whole domain. Yeah, let's do from for example here. These are the just a zooming in the Manila Bay. So as you can see also here, yeah, high resolution, you can better resolve this area, the coastline. Also here, you have perhaps the parent model as a, I don't know, no realistic flow here in this strait, but you can see this in this case anticyclone that are also present in the parent model that a little bit shift respect to the parent model, but the big structure are preserved now, and
Well, we see also a coastal current
He also
going
coastal current.
outward, yes, which is quite important. And if it is realistic, with respect to the parent model.
Yeah.
And
And
also a big difference in the part of the islands that you were pointing out, where the parent model does not have the appropriate topography.
Yeah.
Bathymetry, not both topography, but bathymetry. So you really see here the advantage of the first downscaling, basic advantage. Yeah.
Yeah, I just did this one zoom, but it can be very interesting to check in detail all the area inside all the archipelago, also in this area where there is this persistent. So in order to check the difference between the two current systems. And yeah, so just this as a starting point. And these are the results using all the upstream data that Rita show in the presentation that you can also use, are free, available, and then you can compare and checking with the current system. Yeah.
So this is thank you, Francesco. But let me say, this is another implementation that we did with for you. First, because I noticed that your implementation does not have Manila Bay. Is that correct, Aiko?
Sorry, hello?
Yeah.
Ano daw? Sorry, Nadia, can you repeat?
Yeah. So in your implemented model, your parent model implementation, not parent, you call it, I don't know.
Father.
Father. Yeah. Your father model implementation. Do you have Manila Bay or not?
No, I only got it from Mindoro
Yeah.
to 118 to latitude 8 to 14.
Okay, so I think this this second model that Francesca has developed is a valid alternative that would consider larger area without pushing too far the computational resources. So what I would like to say is that would be worth for you to try to rerun this domain and see if you can support the computation. This is a larger domain than yours, but Francesco made a calculation that should be feasible for you to run it.
Yeah.
And that would allow you to study also the Manila Bay accident with much better currents than are probably done up to now.
Yeah.
So, and especially if you want to do like I heard at the beginning, the subsurface release problem, which is normally, I mean, a delicate one. So, this, I think Francesco did a real wonderful job in setting up this in a very fast time, but he's a real expert on this. And what is missing here, and it is connected to NSAP. So you could start learning from this one, how it is interfaced with a real forecast with a, I mean, you did a forecast or you used an analysis?
I used the analysis for this period in the past, yeah.
But you have the forecast.
We have the forecast, obviously, yeah.
Okay, so one thing that we could do to conclude for you, Aiko, and the remaining people, is to run again this case exactly this week, but with a forecast atmospheric forcing.
Yeah.
So to show the difference, because people don't understand what is the difference, but there is a big difference. At the end, the atmospheric forecast, if it is important in some of these areas, It's going to be very different if you use an analysis or a forecast. So the currents will be different. And so you start to understand what really is the uncertainty in the ocean forecasting due to atmospheric forecasting uncertainty. Yeah, that's another important fundamental step. And so before we send you everything, Francesco, I think it would be nice to run this same example with the downloading of the forecast of NSAP.
Over 36. Number 1/36.
So is there any other question on this implementation that will be offered to you? And so you can try to reproduce first and then start with the NSAP downloading and so on.
Yeah, I think it would be nice if we can get like an example script for downloading from Incept, since we don't have any experience using it yet for Surf Nemo.
Yeah.
And I also want to discuss or maybe I could send first the error files that we're getting for the post-processing of the nested model, because
Okay.
that's the part where we're stuck with right now.
Mm.
So yeah.
Okay. Okay.
I'm sure that part would be easy for Francesco to find out. Yeah, so it's good. Excellent.
Great. Thank you. Thank you so much, Francesco. So if there are no more questions for Francesco, maybe we can move on to the last presentation from Eleta.
Okay. Yeah, I think it's very exciting to see all of these implementations. And thank you, Aiko, and thank you, Francesco, for all your efforts on this. So for my part, well, some of you have seen this actually. It's still like what the title is more on what are the applications. So obviously the concrete, there's already an example of a concrete example case in terms of the oil spill. Sorry, hang on, the presentation thing is not sharing thing is not working. Oh, there we go. I'm just really going to reiterate some of the things that I've already presented during the general assembly, with a few I guess other inputs. So I think that for more going forward, and in terms of where these models will be applied to, this will revolve around several efforts right now, and of course these efforts will should be and hopefully be continued going forward. And so the first effort or soon to start program or project would be the sustain one, or this is the Ocean Decade name for that. But so the main objective for this project is developing the technological and socio-ecological capacities for ocean observation and modeling, understanding and managing coastal ecosystem threats using fit for purpose and co-design approaches. So the project has 3 components, but the framework is that developing the ocean observation aspect. So these involves cost-effective technologies. So K and Cha are involved here as well. And then the second aspect is looking into more on biological and chemical threats. And then there's the stakeholder engagement from community and citizen science involvement. And um, from including from for the ocean observation aspect. And then, of course, these different data information would help in developing, calibrating, validating the models for, of course, the surf hydrodynamic and hopefully biogeochemistry in coupled model. And then so the apart from that, just general resource and risk mapping. And so these applications, there are various applications that can be done, which I'll talk about more with the specific areas in focus. And but the important part here as well is that we are liaising with the stakeholders on site and to help make these models more useful for specific purposes. So I'm not gonna go into any more detail in this because I think the discussions are more important. But essentially, that first component of sustain is the more technological aspect of the coastal observation and developing the modeling system, primarily. So Kay and Cesar and team have been developing this automated water quality monitoring system that we've been deploying and testing in areas such as mariculture areas, near coast areas, and then the hydrodynamic ecosystem models development, and then apart from this is to also develop the databases and system that can provide or can house the information and the models and necessary like services that would be of priority in the areas that we are looking into. And then the capacity enhancement, as Nadia said, capacity enhancement and co-design and application of the tool. So the capacity enhancement is part of this building capacity for more more technical aspects in ocean observation and modeling, and also but also at the stakeholder level as well. So component 2 is more concerned with the chemical threats. So this is with the harmful algal blooms and pollution. I'm not going to go too much into detail here anymore. The third part is integrating with the communities and the stakeholders by cultivating people-centered risk knowledge, building with coastal communities through the citizen science. But essentially, the idea is to strengthen community organization for risk knowledge building with participatory risk assessments, participatory monitoring. So this will also look into kits, tools that would be used by the communities or citizens for citizen science as well, but also enhancing the capacity of the community to respond to different sorts of hazards and coastal risks. So global coast sites. So as of course we all know, there's 3 global coast sites included in the Philippines, and the first one is in sorry, what's there? There. So the one site is in the Verde Island Passage. So I think that's where ICO cut the northern part of the domain, so that includes the Verde Island Passage, but it's below the Manila Bay, right, ICO? So that was a consideration there.
We have another domain now to offer, but
Yes.
you need to
Yeah,
change many domains. I can tell you it's a normal
yeah.
it's a normal procedure you get by successive refinement. That's engineering teaching.
Yeah.
Also, it's good. It's good to start with one, and then you find out maybe you should have taken a larger one, but within computational resources, and IECO gave, had a very good guess.
Yes. Actually, initially, I was asking before, like, can it be the whole Philippines? But then computational, I think that might be too prohibitive.
We will do it with the adaptation fund.
I see. Okay.
Yeah, that's the adaptation fund cloud, which
Yeah.
we will have to pay. I think with 14 million, we can pay a cloud for the Philippines. I think, we should. Not only the Philippines, actually, the whole South China,
Southeast.
the Southeast Asia seas.
Yeah.
Yeah.
Okay. Yeah, so Verde Island Passage is from around approximately on the western part of off of Manila Bay, south of it, southwest of it, and then going into this. I don't know if can you see my mouse? Yeah.
Yes, we can.
Yeah. So around this area, to about here, that area there. And it encompasses that's the one of the center of marine biodiversity in the area. So very much of interest and a very productive area. Big tuna fishery area here. I think in ICO's model, they're showing strong currents in this area too. So I think that's a very exciting area to look into for sure. And this recently, several months ago, an oil spill happened in this area, in Mindoro area too. So I don't know why oil spills are suddenly happening a lot nowadays, but
Because they have always have happened. In
I'm
fact,
sorry.
it's only that we're not aware of them as much as we are now.
True.
They were always happening, I can tell you. We discovered
True.
many in the Mediterranean that, we thought, oh, they did not exist, but they, in fact, we have a lot of oil spill accident, and the more the maritime traffic will increase, the more we will have them. So it's a very important threat that we need to take under control. And the currents, because they're not winds, but the currents are the ones that can come out of this system. In the old times, people were deducing currents from winds, but now, that's not valid anymore. So you have to use these models to give the currents that transport the oil. Yeah.
So definitely, I think this area is the establishing the model here would be very good for assessing the oil potential hazards from navigation, because there's a big port as well in this area also. And then apart from that, the marine biodiversity and connectivity concerns or challenges, and possibly for bleaching as well with the sea surface temperature, the information from that. So apart from the fisheries. And then the other one is just kind of the eastern area. Tayabas Bay is more of a mariculture and fisheries focused area. And so there's a lot of talk about setting up mariculture parks. So assessing the water circulation features here as well is quite important for establishing these kinds of sectors or industry.
Yeah.
And just as an example, we actually started with a smaller bay here. With I was working with Cesar as well for this, where we did a kind of a snapshot circulation model. K and his team did, and then we had a Bayesian model to assess the for marine spatial planning to figure out potential mariculture areas, which are the orange are the low, green is moderate, and purple are the high viability areas for mariculture. And that comes from water quality parameters, depth, of course, bathymetry included, and including the existing ecosystems and uses within the surrounding areas.
So where did
Interestingly,
you take the currents here? Did you
Where
use currents in your viability map or feasibility index?
yes, so they developed it was actually Delft, right? They just used Delft model here.
Yeah, we used the Delft model to compute for water residence time, and then use
Was it Delft 2D or 3D?
3D.
Good.
Yeah. So for that, and overlaying that with the potential marine protected areas as well. So in this case, it turned out that there was no conflict really with a lot of the uses, but we don't know if the government is going to push through it, setting up the mariculture park. But these kinds of things, I think, are especially needed in many parts of the Philippines, and assessing these kinds of for these kinds of situations.
It would be nice to compare from Delft. I don't know if you have output with you, compare this model with what comes out of NEMO model downscaling for this area, because it is contained. And I'm sure with Delft, you use a much higher resolution. What was the resolution with Delft of their model? Do you know?
I think about 100 meters. So that narrowest channel there up in the north of the island.
Yeah.
Just a couple of grid points there.
Yeah.
So 800 meters.
Narrow. Yeah.
Yeah. Was it nested? Do you know if it was nested in the
No, it was just forced by tides.
Yeah.
See, this is the limitation, unfortunately.
And river discharge.
Yeah, this is the limitation, because even if it is 3D, you know, these forcings are typically for a 2D model, tides and rivers. But you know, even Delft not get that. I mean, in fact, you know, Delft has a version which nests into Siemens, but they don't make it available to everybody. So it's still a commercial product. So for, you know, to a certain degree, we will replace, Delft is a very good model, but to a certain degree, we will replace that with SciFem and with the future development, because SciFem will allow you to go to 100-meter resolution in that strait. And you know, this is why we need it's a progress. And now the next, you know, after it is consolidated, the step with Surf Nemo, we have to start to think for you about the Surf SciFem model development, because you will find really an improvement, big improvement. In addition, you mentioned the rivers, which we haven't mentioned for Nemo, but we could have Nemo with some rivers, some idea of river, but really it is Surf SciFem that gets the river. Okay, so 3-dimensional with the rivers and everything. So this is the next step. Maybe we will be ready by the February meeting, where we have the other school. But you know, IECO progress is very important, that gets solid on already on this downscaling because it will tell a lot of stories. This downscaling will tell us a lot of oceanography of the area, which will be useful. Not to the degree of having a real viability map, but to some degree, yes. And then you need the further one, which is the surf SHIFAM. Yeah.
Okay. Okay. Yeah. I mean, I think in terms of the scale of these areas, so there are certain like larger scale processes, of course, and then the zooming into these kinds of details, then the SHIFAM would be needed. So I mean, Aiko already presented the Visayan Sea. I don't wanna belabor that anymore, but as like in terms of the productive areas, also this site is very known for harmful algal blooms. Actually, Aiko, what you mentioned earlier about you went to one of the islands instead of following the track, that Gigantes Islands with a lot of scallops. Now and then gets blooms, harmful algal blooms. And I think it's because of advection, not I don't think it's local because it's
That's
not the
right.
normal area where HABs blooms locally. So yeah.
But where do they come from? We could look at the pathway from the model output.
Yeah.
What it will be the most likely source of these, because hubs normally arrive from other places. There are very few, as you know, you are the expert, so.
Yeah, actually here in the Philippines, the one of the main toxic species has a cyst. So many of it are local embayments. But in some areas like this area, Visayan and Samar Sea, with the adjacent embayments, they can be advected. But in other sites, they're more localized.
Yeah, you know, the Adriatic, we have hubs also as cysts. So there is a blooming all of a sudden, and they were there, but they're local in the Adriatic Sea. But here, yeah, we should find out where is most likely, given the currents, where is most likely, because you have already Visan in the center of the domain of ICO. So that would be, you know, already, if we do the 2 months long, or even should be 1 year long, to see the seasonality of the currents, because here, you know, you have some seasonality of the currents because there are so many straits. Yeah.
Yes. So yeah, so that's Visayan, and yeah, so that's a Visayan. And then I'm just putting here all of the ongoing and future work. So Kay and Charina are heading the pumps and really just to set up the observation prediction system. So we're all, I think, tying up together, integrating to help across these different projects to set up these observation and forecasting systems. And ultimately, this is the goal, long-term goal, to have more a national scale observation, data management, modeling, and services capacity. So yeah, so I think I'll just stop there. That's, anyway, if maybe K or I don't know if Cha is still there, if you want to add anything.
Thank you so much, Leta. So we have, I mean, we're running out of time, but maybe we can have a few more questions, and if there's anything else to discuss or add, please feel free.
So I've also invited Giovanni to come to show the forecast bulletin that we did for oil spill. It would be nice to know about your experience. I guess it's Kay that is doing this work, and hear what are the issues and what do you use as a forecast, as an oil spill model?
Sure, Giovanni.
Giovanni, ikaw tayo ba? So
Like, oh,
oh, I mean, so it's actually mostly me who's running the forecasts and sending it to government agencies. I'm using WebKnown from NOAA. So that's is what we're using for the oil spill model. And then I'm just downloading all the data sets from Copernicus, which is 1/12 degrees for ocean and GFS for winds. But yeah, it's a very low resolution, but it's at least it's enough to show the movement of tides with the winds. Since the data set from CMEMS has the SMOC, the one with tides plus wind, wave plus tide plus surface currents. So that's the one that I'm using instead of the RTOFS. So yeah,
it's initialized from satellite images.
yeah.
So you take the slick from the satellite, the
Yeah.
first
Yeah.
satellite image
And run it from there.
from there. Yeah. See, it will be very important if you, your system, the one you have by ICO, can be used to force Gnome. I never understand how to pronounce that name, Gnome. For me, it's too difficult. Italians, I mean, language, Gnome is impossible to pronounce. Anyway, so, you know, but and it will be much better than anything else, because I mean, to use any other formulation of currents in these interconnected seas is really difficult, especially the bay.
Yeah.
The bay is another one that is a problem. Well, actually, was hoping that Giovanni would come.
I'm here.
Giovanni's
Oh,
here, yeah. Yeah,
Oh,
he's
okay.
here.
So,
Hi,
yeah. So, can you?
Do you have a did you simulate the Manila oil spill? I mean the recent one in these days?
Yeah.
Yes.
Yes, that's what
Okay.
they say.
Yeah. Did you show the results? I mean, were you able to forecast it properly?
We're just using the data from Siemens, from Copernicus and from GFS, and then we send it to all the government agencies who's involved in reporting the oil spill.
But do you have a result to show?
Reports of sightings of oil along the coast
Kita ko ba
are
dito?
consistent with trajectories from the model.
MSI.
ICO can show some.
I think I can show the bulletin, but not the videos.
Yeah,
Yeah.
the bulletin, if you, because then we will show you ours that we did also from a global model. We
Or
have,
one I can show first if you need to search, and then you show afterwards, as you prefer. Oh no, okay.
So this is the ito naman tayo sa duplicate natin. There. Can you see?
Yes.
Yes.
Yeah. So that's the bulletin, the latest bulletin we released. So mostly we expected it to, we just used the TerraX, excuse me, TerraSAR-X image from Copernicus. So that was dated July 27, 6:10 p.m. in Philippine time, because we have to report it in Philippine time for all government agencies, and we expect most of the oil spill to go towards the southeast side of the Manila Bay. So mostly from Cavite City to Ternate. So that's what we got from our recent run.
Sorry, can I see the date of the Copernicus, the map? It was 27th.
Yeah.
So, you know, why is, and this is shows a northward direction for the spill. Why wasn't your northern coastline, I mean, real Manila kind of coast stretch affected?
Oh, so this one is like the bulletin 2. I
Yeah,
can show the bulletin 1
that's
here.
right.
So this is the first run that
Yes.
we sent the government agencies. So
Yeah.
this is based on the first
Yeah.
shapefile sent to us by our local by Philippine Space Agency. This is also through NOAA. And then we use that as we use the combination of point release from the sunken ship and also the image, and then run it via web genome.
Yeah. So in fact, you did get oil on the on the 28th of July on the northern shores.
Yes.
Yeah, that's what I meant. Typically, this is the first release, but then you have also the other image from what is the name? Is Terrasat? I don't remember the name.
Yeah.
Yeah. You have the other images shows that the farther spill went southward.
Yeah.
Yeah.
So that's when the Philippine Coast Guard also contacted us, because they are also running their models with the same oil spill model with WebGNOME, and they called us and told us that they're finding out that the wind is changing eastwards. It's moving eastwards. So we also run our own so we can compare, and then they can deploy their personnel there right away.
No. So
Okay.
very nice.
I can show what we did.
We have an oil spill model ourselves, which is open also source. Unfortunately, we don't have the web with oil anymore, but it will be restored soon.
So this is let's look first. So we have run the same. Actually, we didn't start from the satellite image. So we start from the ship position, a continuous oil spill, and we have run it starting from 24th. And here is the comparison of two models. The first one is CMCC GOFS, is a global ocean forecasting system at 116. And the other one is CMEMS. So we just did yesterday the new simulation, which behave similar, let's say. GOFS extend a bit more to the north. The scale here in color is the concentration of oil. And then so this is now we are running the simulation, so we have another one
with the two different currents from two different global models.
Yes.
And also overlaid is the slick from satellite for exact time. Okay, so maybe it's you can make it bigger, though we can see the slick superimposed to see how good is the forecast.
Yeah. Let me do it. So here is the. Do you see my screen?
Yeah,
so
we
here is
see.
the new satellite. Yeah. Here is the new satellite from 10 o'clock UTC. We got this satellite image. We are not starting from any satellite image, so we are running still a continuous spill from the point source. Here on the top you have GOFS, CMCC, and here in the lower part we have CMEMS. which is
You
moving
cannot see
towards.
CMMs. We cannot see CMMs.
Say it again.
We cannot see. We see only GOFs.
Do you see now?
No. Your page does not move, so.
Let me stop sharing the share again.
So this
You
is
see
done
now?
only with currents from global systems, clearly are inadequate for getting the complexity of the current advecting the oil.
Do you see now?
We see something. I don't
So
know what it is.
no, this is Copernicus Marine Service currents forecast for 22 compared with the satellite image of 22.
Yeah.
Okay, so that's better than GOFs.
Yeah. Yeah, GOFS is this one. Is all
Global Ocean Forecasting System.
That's why we're using CMMs too on our side, because it cannot get that same movement within the bay.
Sorry? Can you
Um,
repeat, Aiko? Because there's some issue on, I don't know why, on the,
okay. So initially we were running using GOFs too. We're also using the GOFS, and then since we found differences between GOFS and CMEMS, we also told PCG, our Coast Guard, to try running it with CMEMS with Copernicus datasets, so that we can also consider the effects on with that change in forecast. That's why we have shown in our bulletin that we expect it to reach the southeast side of the bay. So that's
sorry,
what we're.
how could you run with GOFs? GOFs is not a
no,
very,
my GOFS is a misspelling. GOFS, when I say GOFs, is our CMCC Global Ocean Forecasting System,
okay.
not the US one.
The one we were using is the one from the US
from
at
the
first.
US.
Yeah. And
sure.
then we changed it to Copernicus because we
Okay,
can
so
see the effect of tide in that data set.
okay, in Copernicus, there is no tides. So if you want to add the tides, but that's not very important, the tides. So I can tell you already, you can run everything without tides. This is something the Coast Guards still have to get their mind around. But you use the CMEMS, did you?
Yes.
So you should have, Giovanni, can you show the CMEMS simulation? I don't understand why you cannot share
No,
well.
I'm showing it. I didn't want to distract. So
And then
this is the CMEMS.
Okay, so you see, starting from, I mean, not the CMEMS, starting from 24th.
Yeah, it's still starting from 24th, continuous
Cannot
speed.
hear your voice, it is broken.
I don't know why. I tried. So this is Copernicus Marine Currents, CMEMS currents, starting from 24th of July, continuous spill, and
Up to the 27th, so 3
up to
days
the
without any tides.
yeah.
Okay, so tides are not important. Tides are only important eventually to resuspend oil that has arrived at the coast. But for the transport, these are the currents that do the work. Okay, well, clearly it would have been much better to have Francesco's currents. But also here we show that the quality of the global products that we use is also important. Not all the global models have the same quality. And so CMEMS gives a good displacement, reasonable displacement. GOFS, which is the CMCC global forecasting model, which we never show you before. Okay, we have also that, but it's still experimental, gives you a not so good advection. Okay, and I just wanted to say that it is really the thing that is driving oil spill modeling. We have a full suite of papers documented this in the past 15 years. We have started to do oil spill modeling 15 years ago. Is really connected to these currents from these models, and they're becoming better and better, but clearly they should be helped by downscaling. There is no other way. There's no other way. The rest is all ad hoc, and is, every time you need that specific person that knows how much wind I have to put in addition to the waves, in addition to to make it working. But that's not real operational system. Operational systems should be automatic or semi-automatic. Okay, so this is good now, Giovanni.
Yeah, this is good. Now we are running the simulation starting from the satellite image, from this one onward. So I will give you the results as soon as we get them today.
Did we lose Giovanni, or is it just my internet connection?
I say yes, I agree, it's better now, and we will run also the simulation starting from the satellite image.
Great, thank you, Giovanni. Does anybody have any other questions?
Yeah, maybe we should foresee to have in the next course a few hours dedicated on this application, a posteriori application of our oil spill, and compared with NOME. We haven't done this comparison a long time. I just wanted to show this. We have reestablished, because every time we change the system, we have to restart, but we have restarted our website. I'm gonna put it here, and MEDSLIC 2 is called MEDSLIC. Okay, this is the site. And we will be very happy to also get your community involved. As you see, it's a large community that has been working with this. You find all our publications here, that many of these applications about MEDSLIC modeling in connection with operational oceanographic products. So here it is. And you can download it. It's done on a virtual machine, like for surf. I just wanted to stop share and show you the, what is it? Put on the chat the website. Yeah. So you have now there. You can look at it, and we might have a session in the next course where we talk about MEDSLIC, or not MEDSLIC, but oil spill modeling.
Yeah, Nadia, I think it would be very interesting for us also, and And then, of course, we will simulate also the oil spill event using Francesco Trotta new high-resolution model, I mean, the one that has developed. So I think that also will teach us the importance of downscaling, hopefully.
Great.
Oh, by the way, sorry. Just a note. The original we were talking about the training later this year, but we've moved it to the next year.
So next year, February, and the February start of March. Yeah.
The one here in the Philippines on face to face.
We're finally coming to the Philippines.
Finally. Just tell us when it will be, because February to April is usually a very active time for us to do field work, since it's the best time for us to go out to sea, so that we can block out that schedule.
What was the
So we were planning from 24th of February till the 7th of March. And we were
Please
Sorry?
block that.
Yeah. So we were planning to have the first week like online sessions, and then have the second week in person in Philippines.
Okay.
Will it be okay?
So both. Do you have any plans for cruise? No. Okay.
Put it in your calendar, DK.
It's always very busy.
Yes.
So from 24th February to 7th March.
Yes.
The 24th would be mainly virtual to start put up to you know put more you know modeling tools available so that people can start using them, and then when we come we should do real work on the models that we have and the applications that we want. Just to say, I hope I can get also some of our coupled biogeochemical model with you know with at that time. So hopefully we will come also with the people that do the coupling of our biogeochemistry, or the one-dimensional biogeochemistry, which I strongly advise to start with. And so have some opportunity to show what we can do and how we use it at this time. Yeah.
That sounds great. Awesome. So just before we end, anybody has any other questions or anything else to add? Sorry, we went a little, not a little, quite overboard, but I think it was very informative and I believe very interesting for everybody. I hope everybody got to learn a lot. The presentations would be available on CoastPredict's webpage once they're forwarded to me, and all the presenters have shared their email addresses. So if anybody has any questions or if they want to get in touch with them, you guys can. And if there are any other questions, feel free to email me and I will respond to them as soon as I can. Okay, well, it was really nice seeing you all, and thank you so much for joining, and thank you so much for your time and presentations. It was certainly very great. Hopefully you guys have a great rest of the week, and we will see you guys again next year in February.
Bye.
Perfect. Ciao, ciao. Bye.
Bye.
And
Bye bye. Ciao.